Thank you everyone for joining the webinar today. We're going to be learning about steam and gas turbine data interpretation. My name is Michael Lyon. I am the Industrial Plant Manager for Fluid Life, and I'll be your presenter today. If you have any questions, you can ask them in the chat window. We will answer questions at the end of the session here, so please, as you come up with them, write them into the chat bar, and we'll get to them at the end. If we run out of time, we will reach out to you personally and answer your questions that way as well. Today's session is going to be filmed or recorded for further review afterwards, and you can take a look at that and ask your questions to us afterwards as well. So afterwards too, if you want to have questions, you can reach out to myself, Michael Lyon, or to customer care at Fluid Life, and it'll be available on fluidlife.com. Today's session topic is going to be data interpretation for steam and gas turbines. We're going to cover a number of topics, but first of all, when you're interpreting results, you have to take this three-step process. First is to interpret your results, figure out what's going on, and so you have to have your questions, your knowledge of the situation, and any additional perspective, whether that's from your OEM or your oil supplier, or from your technician. Step two is to decide, so weigh your options and make a call. And step three is respond. And respond can show up as a number of different things, whether that's just to ignore the results and wait for the next step, or gather more perspective. Ask your outside sources for some help. Monitor more closely with some more testing or different testing, perform inspections, or actually react to those results, whether that's oil changes, filters, or any other additional resources you may have to solve the problem represented by the oil analysis results. So gas and steam turbines are very complicated systems with many, many moving parts. Some turbines have integrated lube systems with large reservoirs, and others have separate lube control oils and lube oil systems, and both are going to have their own unique problems depending on what type of turbine you're running. A lot of turbines either operate continuously in what is called a base load capacity, or on an intermittent basis, which is called a peak load facility. Different issues are going to arise from different types of operation, with your peak facilities running into a lot of varnish issues, and your continuous base loading operations with far less issues actually. Less wear, less varnish, or at least less opportunity for varnish to cause issues. Turbines are obviously extremely hot and wet, and so with these extreme stressors, there's more unique challenges that you may face. Long life oils also need extensive monitoring and planning, as a lot of these oils are going to last for a decade or more inside your turbine if taken care of properly. There are three main types of lube oils in use in turbines. The most popular one being your standard mineral oils. These mineral oils are very prone to varnish, which are hard, sticky deposits. They are soluble with varnish, and most will differ between groups 1 to 4. And varnish removal filters are something that you should be thinking about if you're running a basic mineral oil in your turbine. The second most popular would be your polyalkylene glycols, or your PAGs. A lot of these, though, are replacing the old mineral oils these days, and so they're prone to incompatibility issues. Replacing a mineral oil with a PAG can run into all kinds of problems, and so you definitely need to be talking to your oil supplier and the lab to make sure that you're not going to run into any of these issues if you're doing a switch. Phosphate esters are another one of those new but fairly rare oils. They're prone to hydrolysis, and so if you have water in a phosphate ester, you get a chemical reaction of acids and alcohols, which are going to be very damaging to your system, causing metal leaching and other equipment type failures. So controlling the moisture and monitoring acidity is essential. You must make sure that there is no water if you're using any sort of phosphate ester. And you can also remediate phosphate esters. You can reverse that reaction of ester plus water And so you can use things like Fuller's Earth and activated alumina to basically reverse that reaction and bring it back to an ester. And so these oils can last a long time, again, if you're taking care of them. So how and when to test a turbine? This is all determined by a number of factors. The chart we're looking at here is actually from Mobil Oil, their technical training guide for turbines. And so they recommend kind of a monthly or quarterly type analysis. And this is from Mobil themselves, but everybody has their own guidelines when it comes to sampling a turbine. So it's good to kind of take all of the considerations, whether that's from Mobil, from Siemens, or from any of the turbine manufacturers, as well as lab recommendations, and deciding for yourself what is going to be best based on your oil type, your turbine, and your operating conditions. And so really we're not going to spend too much time on how and when, because it is quite unique to the turbine and your situation. But feel free to reach out to us at Fluid Life, and we'll help you design your own oil analysis program. So testing your turbine's oil, Fluid Life has a number of standard and advanced tests for turbine testing. We recommend these tests here: viscosity, ICP, the acids, particle count, water. These are all your standard tests. And then your more advanced ruler, demulsibility, RPVOT, rust, foam, and varnish. These should all be done as frequently as you can, but really paying attention to the results is what we're going to be talking about in a second. And just before we go into the actual test results, Fluid Life does have a number of different packages designed for industrial plants. The Plant 5 package on the far right is our annual turbine package. This is a GE recommended testing slate that we've designed specifically for turbines. This is something you would do once a year per turbine, followed by probably a Plant 4 for your regular monthly or quarterly sampling, so that you get your varnish potential and the rest of those kind of critical tests for early monitoring. So we're going to jump right into the tests and kind of what they mean and what you're expected to see on a turbine. Viscosity is your number one test in terms of all samples should be getting this. And in a turbine oil, whether it's a mineral, a PAG, or an ester, it's going to remain fairly steady throughout the life of that oil, even through contamination of water or particles or anything else. It's going to remain fairly steady. Really what you want to see here is slight over time changes. Because these oils last for many, many years, you'll see this kind of either thicken or thin over time, and you can make decisions based on that along with the rest of your data. But the general rule of thumb here is it's not going to change too much, and it's definitely not going to be the smoking gun of your reactions for your turbine oils. Water contamination is definitely one of those things that you have to pay attention to very closely, whether you're using a mineral, a PAG, or an ester. It's one of the most common contaminants, and this report you see here, it kind of fluctuates up and down, and something that you'll see on almost every report, especially on a steam turbine. And so regular water removal is definitely something that everyone should be thinking about when monitoring your turbines. Whether you have centrifugal water filtration or separators on your tank, a headspace air dryer which blows warm nitrogen across the top of the headspace to draw solubilized water out of the oil, or just regular tank draining. If you have a large reservoir, you can just drain the tank ever so regularly, once a week, twice a week, to get rid of a lot of that water that is settled out at the bottom. And that can become a regular PM just to get rid of that water as much as possible. ICP results, as you can see from the example put on the slide here, it's also very boring. There's not a lot of small metal wear generated in a turbine. And three things to keep in mind wear particles analyzed are generally limited to 5 to 6 microns. So anything you see in this line of the report is going to be very, very small particles. And so there are supplemental tests that you can do to analyze wear metals, whether that's analytical ferrography, which is an image of your oil under microscope. And so you can see anywhere from 5 to 100 micron particles using a ferrography, which are then classified into the type of wear and shape. Or something like an SEM, a scanning electron microscope image, which is going to look at your very, very small particles, the 1 to 5 micron range particles that are showing up. And this is done through a very intense microscopy method, which I'm sure most people are aware of. But this can give you more and a better picture of what type of wear is being generated. If you do see a lot of metal wear in an ICP analysis, that means you've got a couple of other problems happening. Other factors in the oil are contributing to metal leaching or spalling, or possibly even metal being created from cavitation, maybe foam in your oil. And so it's usually a big deal if you're getting flags on your ICP analysis, but really they're going to be boring most of the time. And your main focus here should be the changes to additives. A lot of turbine oils have very low additive levels, and so it's very easy to spot when you have outside oil contamination, maybe a shared barrier in which a different oil barrier fluid is getting into your turbine oil and maybe contaminating it. And so watching those additives is very important to make sure that you're not having any of those sort of issues. Acid number is the next aspect we're going to look at here. Generally, it's going to stay very low. A large increase in acid number, or even a small increase in acid number, could mean that you're running out of your oxidation protection. The main thing that a turbine oil experiences is oxidative stress. And so when you have increased oxidation, it's going to increase your acid levels. But turbine oils, all turbine oils, any of the three that we mentioned earlier, have a lot of different protections, whether that's phosphorus as an additive or the innate ability of the molecules of the oil, the amines or phenols, to fight off that oxidation. So once that oxidation potential or protection has depleted, you start to see increases in your TAN. So small changes in the acid number can mean the oil is spent. An increase of 0.4 or more can mean a loss of oxidation protection. So if you suddenly see it go from 0.06 to 0.3, that is a big red flag that you need to start doing something to your oil, and you need to make a decision on changing or remediating that oil immediately. If we move on to the isoparticle count, first I'd like to describe what the isoparticle count is. And it's this 3-number code here, in this example 16, 14, 10. And these numbers directly relate to these 3 columns here in the report. The 16 is directly related to your 4 micron count. The 14 is directly related to the 6 micron size particle count. And the 10 relates to the 14 micron count. And so each increase in an ISO code is a doubling of particles at that size range. And so to go from a 16 to a 17, we'd go from 370 to a 740 roughly. There is a size particle range there that it can go for. I believe this one is 300 to 600, and then 600 to 1200 particles for the increase. And really the goal here for a turbine oil should be to keep it as clean as possible. There are a lot of small, tight clearances in turbines, control oil valves and pumps and whatnot. And so any small particle contamination that's in there will cause metal cutting and wearing. And so the cleaner your oil, the longer your equipment will last, and the longer your oil will last. So really, choosing a target goal for isoparticle count is really up to you on where or how clean you think you can keep your oil. but it may require some additional filtration, kidney loop systems, or an upgrade of your existing inline filtration to maintain that low particle count, as well as any pre-filtration of oil before you put it in the turbine. And so you have, this is the new oil. It's actually much dirtier than what's expected in the turbine. And most new oils are dirtier than what should be run. And so any pre-filtration of new oil should also be mandatory for any turbine application. Varnish potential is our next test. Varnish potential is this last number here in the red flag. And so varnish can very much fluctuate from sample to sample. It can go from 10 to 50 to 20 to 70, sample to sample, depending on when you took it, what was the turbine operating, was it cold, was it hot, what time of day. It can really fluctuate in what the varnish potential can do. And so if a cold oil sample is taken, a lot of that varnish that's been solubilized in the oil will plate out onto cold surfaces of the turbine and then show up on a report as a very low number. But then you turn that turbine back on, you run it up to heat, and you take another sample, and now we've got a 75 varnish because all of that varnish has been resolubilized into the oil. And so really the way you want to look at varnish results is major trends. Think of the stock markets. There's the daily up and downs that your day traders are looking at, but the long-term economists are looking at the upwards or downwards trend that those results are giving them. And the same is true for varnish potential. If you have an upward trend in varnish potential, then it's possibly a problem. But again, varnish is not going to be a smoking gun test for turbine analysis because they run so hot and they are so prone to water contamination. Varnish is a constant issue. And so there are other things you can do. You can add electrostatic discharge filtration or stacked media filter that absorbs varnish in kidney loops or in your inline filters to help remove the constant increase or growth of varnish in your system. You may also notice varnish in your tank. It often shows up as a sticky brownish gold bathtub ring inside of reservoirs. And so if you touch the side of your tank and your finger sticks, that is a sticky layer of varnish that's been deposited inside the tank because it's much colder than the rest of the system. And it also often coats out onto cooler systems, reducing their effectiveness and insulating them like a blanket. And so it becomes a cascading effect of more varnish creation the more that it plates out onto the cold surfaces. So again, it's a very important aspect to keep your eye onto, but it's not the smoking gun that's going to tell you to change your oil or do a remediation effort. Demulsibility is our next aspect. And so demulsibility is the measure of oil's ability to hold on to or shed water. Most mineral oils, and that's mostly what we're going to talk about here, you don't normally run a demulsibility on esters or PAGs, but on a mineral oil, it's designed to shed water. It wants the water to sink to the bottom of the tank so it can be removed. And so this test is a measure of that ability. What we do in this test is we take the 40 mils of the oil sample, put it in a beaker with 40 milliliters of distilled water. We mix that up mechanically and then wait for 30 minutes. And by the end of the 30 minutes, we measure how much is emulsion, mixed oil and water, how much is free water, and how much is oil. And so basically a perfect test here, 43,370 to oil water emulsion after 15 minutes. That's a good example of an oil that sheds water very easily. And you can see that it's actually starting to deteriorate. And so it's starting to hold on to water a little more. After 30 minutes on the most recent sample, it's now at 7 emulsion. And so it's starting to hold. And then the second sample, we have a complete fail. It is mostly emulsion after 30 minutes. And this is something that they have to worry about. The difference here, or the kind of key consideration, is the size of your reservoir. If you have a very small, say, control oil tank with maybe 100 liters of oil, and your demulsibility is no good, then that oil is going to stay in emulsion. It won't have residency time in the tank for it to separate the water, and it will force emulsion into your system. And then it gets very hot, it creates acids, it causes all kinds of other metal wear. But if you have a very large tank, so say we have a failed demulsibility with a 1,000-liter tank, now it has a long residency time in the reservoir, and it's able to shed that water, maybe even an hour, and so it becomes not as much of a problem because of our large capacity reservoir. So again, you have to take in all considerations of tank size, turbine type, oil type, when looking at these demulsibility readings. Next test is foam, and foam is a unique one mostly for your mineral oils. And we measure two aspects of foam: the tendency, or the rate at which foam is formed, and stability. How likely is that foam to pop through the anti-foam additive, or silicon, which acts as a surfactant, which pops bubbles in your oil. And so this is actually an example where there's a lot of tendency. We mix up the oil and aerate it with an air tube, and lots of foam formed on top. But after 10 minutes, none of that foam remained. And so is that a problem? Again, not really. If you have a very stable oil, it's not going to allow foam to be pulled through the pump and into the system. And but if it's not stable and you have a lot of foam forming and it's also sticking around, that foamy oil can get pulled into your system, and under very, very high pressure, it's going to cavitate, which causes this extremely hot little tiny micro explosion inside the pressurized parts of your turbine, which is going to cause spalling, localized varnish production, because it's extremely, like 1,000 degrees or plus when it cavitates, and it's going to really cause havoc. You'll actually hear popping in your turbine when you have cavitation. And so this is a really bad problem if it's stable, or if it's not stable. But again, this is actually a good result. 590 foam is fine as long as it's not sticking around. So when reading the results, really pay attention to stability and not so much to the tendency. Ruler and RPVOT are two direct measurements of oil oxidation stability. And so the RPVOT, or what it stands for, Rotating Pressure Vessel Oxidation Test, is a direct measurement of the oil's ability to absorb oxygen. We take your sample, we put it in a closed container, pressure vessel. We inject a known amount of oxygen into that vessel with an oxygen meter reader. It's rotated in a hot oil bath, and the time it takes for all of that oxygen to be used up that was injected into the system is the time of the RPVOT. And so a very high RPVOT is a good number, a low RPVOT is a bad number. In this case, we have a 64-minute RPVOT, and this is something saying that, hey, this oil is right near the end of its life. It can't handle too much more oxidation. And so this result does go hand in hand in the ruler. The ruler stands for Remaining Useful Life Test, and that's these two numbers here, ruler 1, ruler 2. Ruler 1 is this first bump on the graph here. This is the full ruler graph that we distribute with your results. What we're looking at here is the green line is the brand new oil. The red line is the used sample. And so you're measuring these bumps. The first bump here is your amine oxidation removal groups. And then the second bump is your phenols. Some oils have both. Some have just ruler 1. Some have just ruler 2. It depends on the type of oil you're using. but it's a reductive thing here. So our results are 31%. You can see that we're about 70% off of that new oil. The second one is 15%, and we're about 85% off of the new oil for ruler 2. And so this is a good measure that we usually recommend to do annually. And it's going to tell you how much life is left in your oil in terms of oxidation stability. Because like I said earlier, it's one of the most important aspects of your report is how likely is this going to create acids and how much defense against acids do you have left. And so I would say in this report, we've got about, hard to say, but maybe a year left of operation. It's kind of a rough number, more of a guess, but it allows you to plan well into the future for an oil change or getting somebody in to do a remediation on this oil. So again, take these results with the rest of the results. Make sure you're comparing it all together, not just one aspect against another. But hopefully that's giving you a little bit of insight on the tests that we use for turbine oils. The last slide here I have is about oil compatibility testing. Recently, or at least in the last 2 years, there's been one case of mobile Terezzo no longer being available and it being replaced by another oil. And so there is an ASTM D7155, which is a standard used to compare turbine oils by mixing and cooking them and then doing full 4-tier testing protocols to ensure that your oils are compatible. And because whenever you change a turbine, there's no way you're going to get all of the oil out of it. They'll be left with 5 or 10% of the old oil. And so you have to make sure that at a lot of these different mixtures, that these oils are not going to interact with each other negatively and cause a failure. And if any of these tiers of testing fail, then the oils are deemed not compatible and they should not be used together. Or at least all protocols should be used to ensure that you're not replacing just a small amount or partial amounts when doing a turbine oil replacement. So we can do this as well for you if you are having troubles with your oil replacements or you're thinking of making a change to esters or PAGs. We can do these sets of tests for you and make sure that there's no problems. So how can Fluid Life help? We are laboratory services. If you need to upgrade your current test package, reach out, or you wanted to add some a la carte testing to your turbine to get a better picture, just let us know. We also offer private training, data interpretation, certification courses, and a whole slew of different reliability services, benchmarking and audits, optimization and improvements, data interpretation, advanced analysis. So I hope that you learned something today. I know it was just a short 30-minute training webinar, but please feel free to reach out to us anytime if you have questions. We'd be happy to help. And again, hope you learned something today. Thanks for joining, everybody, and we'll talk to you soon.